Imagine your phone instantly recognizing your voice, translating a foreign conversation in real time, or your car steering itself down a busy street. Behind these jaw-dropping feats is deep learning, a secret sauce powering today's AI miracles. But how exactly does a machine learn in ways that feel almost human? Stick around, because once you peek under the hood, you'll see it's less magic, more mind-boggling math and data wrestling. Before deep learning rocked the AI world, computers struggled to make sense of messy, complex data. The breakthrough, teaching machines to spot patterns on their own, like a detective piecing together clues. Back in 2012, Google's deep learning team stunned the world by winning the ImageNet challenge. Their system didn't need hand-coded rules. It learned to identify cats in millions of images all by itself. Suddenly, computers weren't just dumb number crunchers. They were seeing the unseen, recognizing faces and objects better than ever before. Think of neural networks like a stack of detectives, each layer passing on clues. The first layer spots edges and colors, the next shapes, the top layers recognize complex objects. It's like breaking down a mystery scene piece by piece. Each detective contributes to the bigger picture, making sense of chaos through their combined insights. Thanks to exploding data volumes and computing power, deep learning thrives at scale. The more data fed into these networks, the sharper their pattern spotting gets, transforming AI from academic curiosity into practical powerhouse. It's the secret sauce behind voice assistants, driverless cars, and everything in between. Machine learning sounds like wizardry, but at its core are just two surprisingly simple but powerful algorithms. Let's unpack how these really work to teach AI to improve over time. Imagine you're standing blindfolded on a mountain searching for the lowest point. Gradient descent is like taking small steps downhill, guided only by the steepness of the slope you're on. In deep learning, this slope is the error difference, and the algorithm tweaks millions of parameters bit by bit to minimize mistake, gradually honing performance. Backpropagation is the secret messenger. Once the network makes an error, it sends the blame back layer by layer, adjusting its inner workings. Picture a game of Whisper Down the Lane, but instead of gibberish, it's precise instructions on what to fix. This feedback loop is crucial. Without it, the network wouldn't know how to self-correct. Put it all together, and deep learning models learn through persistent trial and error, refining hundreds of millions of connections until they get it right. It's like perfecting a song by replaying and tweaking notes, except the AI does thousands of iterations per second. This relentless refinement lets AI master speech, vision, and even creativity. Deep learning's evolution isn't slowing. From novel architectures to emerging challenges, the future promises new ways AI will reshape how we live and think. Generative adversarial networks, or GANs, are like AI playing cops and robbers with itself. One network tries to create fake images so convincing it can fool the other one, which tries to detect the fakes. This contest drives the system to craft eerily realistic images, art, and even fake voices, blurring the line between real and artificial creativity. Capsule networks tackle a deep learning blind spot, understanding how objects fit together spatially. Instead of just recognizing parts, capsules understand their relationships. Imagine identifying not just a nose, but its position on a face. This fresh approach could fix problems that trip up today's AI, especially in complex 3D scenes. With great power comes great responsibility. As AI grows smarter, ethical questions multiply. How do we avoid biases hidden in data? What happens when machines make decisions impacting lives? Kelleher flags these challenges, reminding us deep learning's future isn't just technical, it's profoundly human. Remember that blindfolded hike searching for the mountain's low point? Now you know it's gradient descent guiding the AI's path, step by careful step. The machines you use each day are quietly mastering complexity beneath the surface. So here's your move. Next time an app surprises you, think about the invisible detectives and whispering messengers behind the scenes. That curiosity is your doorway into the AI revolution. Subscribe for more book summaries like this one.